So I'm just going to give a very small introduction to every speaker. So that's my job as the moderator. So my name is Lukas Seehausen. I'm a research scientist at CABI in Switzerland, and I'm going to moderate this part about establishment biocontrol. And the first speaker is Marc Kenis, who is the head of the risk analysis innovation ecology section at CABI in Switzerland. He's an entomologist with more than 25 years of experience in the 35 years already. You should do an update of the website. In applied and environmental entomology. So he has lots of experience in risk analysis, impact assessment, biological control, integrated pest management, and he's gonna give based on this knowledge, the introduction into the section. Go ahead, Marc.
Thank you, Lucas. Actually, I just counted in my head, it's only 34. Okay. Yes, I'm going to present you briefly establishment biocontrol. Establishment biocontrol is a new term invented in France again. They also invented lutte biologique par acclimatation, things like this, but the rest of the world usually says classical biological control or biocontrol by introduction. You know, French people like to invent new words, but where is, oh yeah, here. This way? So how does it? Oh, the other way around. Oh, sorry. So 34 years of experience doesn't make me more clever. But I started when all these things didn't exist yet. Huh? So you have to think of that. Okay, what is classical biocontrol or classical biocontrol by establishment is the introduction of a natural enemy of exotic origin, usually, always of exotic origin to control a pest, usually also exotic, aiming at a permanent control, a permanent establishment and control of the pest. Usually the target is an insect or a weed. There are also other examples targeting other organisms, but we are only going to talk about the most frequent targets here. So basically, for example, everybody knows Drosophila suzuki. It comes, of course, from East Asia, and it arrived some years ago to Europe, and at the same time to the US and Canada, and then classical biocontrol will be to go back to the region of origin to see what control is there, because usually when there is an invasive species coming to a new continent, invading a new continent, it arrives without its natural enemies that usually controls at least partially, often entirely in the region of origin. So just a few words before, because a lot of you don't know how we do classical biocontrol. Just a few words on the process, on the stages of a classical biocontrol program. For example, taking the example of an ongoing project at CABI for the moment against the box tree moss. So the first step is the evaluation of the problem. Is it a problem sufficiently important enough to invest money at the beginning and so on? Then we looked at the literature survey, what has been done in the past. Is it already invasive elsewhere? Do we know the natural enemies in the region of origin? We have to establish collaborations because classical biocontrol is always based on collaborations between two regions, usually two continents. Then once we find the problem sufficient, important enough, we choose the region of investigation. Usually it's the region of origin, but sometimes it's not possible or difficult, and then we choose, for example, also we can also choose regions where it has been previously introduced and controlled by biological control there. Then we start the inventory on natural enemies, and we study their role as mortality factor in the region of origin, looking at which are the most important natural enemies. And then we start studying them, first in the region of origin, also in the region of introduction, but then in quarantine. But then we focus mostly on the biology and the ecology of the main species, but we focus especially on their specificity, because we don't want to introduce a natural enemy, a parasitoid or a predator, or a weed biocontrol agent that will be harmful for native biodiversity in the region of introduction. Then we choose a species to introduce with priority lists. We make petitions, not us usually. Usually it's a governmental activity. So we just give the data and the governments are doing the petitions. And then once they receive the approval, which is not yet the case for the Box 3 Moss project, we are just in the period of investigation, in the step of investigation. But once we have the approval, we increase the laboratory rearing to have a certain amount of parasitoids, predators, or weed biocontrol agents to release. We choose the region, the release zones, and then we make the releases. We verify the establishment, we assess the establishment, we distribute the biocontrol agent in the invaded zone. Sometimes it's not necessary. Sometimes the biocontrol agents go so fast that it's not necessary, but in many cases it is necessary to distribute these biocontrol agents during several years. And then we finally evaluate the project. This is rarely done, but this is very important because we want to know why it failed or why it is a success. But usually the donors, when it fails, they are not happy and they don't want to give money. And when it succeeds, when they are very happy and they also don't want to give money. So we are in this issue very often. So very often we know that we have a success, but we don't know why and so on. Okay, so does it work? Of course it works. When the first case, and this is why it's called classical biocontrol, because it is except with some biocontrol activities done by China a long time ago, the real biocontrol activity in the modern times started at the end of the 19th century with the Rhodolia beetle against the cottony cushion scale in California. And since that time, there have been more than 6,000 introductions of insect agents against almost 700, more than 700 insect pests now, because the data are only until 2010. And we have about 27% of the insects have been controlled in at least some parts. This looks low, but this rate is actually underestimated because it would be much higher if badly managed and incomplete projects were excluded from the database. The success rate is even higher for classical biocontrol against invasive weeds. I think from my colleague, it seems that they claim about 40% success in the projects in general when they are well done. So just an example, it's not necessarily the most spectacular one, but since we are in France, we take the most recent one. This is the example of the control of the Dryocosmus coryphilus, the chestnut gall wasp, by the introduction of an Asian parasitoid. This is not the data from Europe yet, although the success has also been achieved in Europe, but we don't have the good data yet. But for example, you can see that from a similar program earlier in North America, that once the parasitoid was introduced, Dryocosmus coryphilus density strongly dropped. And we have dozens, if not hundreds, of examples like this in the world. What are the advantages of classical biocontrol? Well, the biggest advantage is that there are huge benefits because the control is continuing year after year without further cost, at least in the ideal case, the parasitoid, the predator, or the agent of weed biocontrol does not need further action. Once it is established, it does the work by itself. Especially, there is no cost for farmers, in contrast to most other different biocontrol and non-biocontrol pest management activities. Farmers usually don't pay anything for classical biological control. And the cost-benefit ratio can be used. For example, one of the biggest successes in classical biocontrol has been achieved against the cassava mealybug, which was a terrible pest of cassava in Africa in the 70s and 80s. And then a parasitoid has been introduced from Latin America, from the area of origin of the pest. And in the 90s, they calculate a cost benefit between 1 to 200 and 1 to 500, which means $1 invested brings $500 for the farmers. Of course, if you would do the calculation now, you would reach much higher levels simply because the cost benefit decrease or increases in a way year after year because there is nothing to do and the farmers still benefit from this introduction. Of course, it's also much safer for human health and the environment than pesticide use and many other methods. It can also target environmental issues, environmental pests. Just one example, for example, Insignortesia insignis is a scale insect which threaten an endemic gumwood tree in St. Helena, this small island there in the South Atlantic. And the trees were saved by the introduction of a ladybird from the Americas in the 90s. There were only 1,000 trees left, and they would have disappeared if we had not introduced this ladybird. I should say that most classical biocontrol projects against weeds target environmental weed, in contrast to insects where the motivation is mainly agricultural or forest or at least economic. Most classical biocontrol projects against weeds target environmental weeds, not agricultural weeds. Of course, there are some risks involved with classical biological control. There is a potential risk to non-target effects on native biodiversity if you introduce a parasitoid or predator or herbivore. So it may attack other insects or it may attack other plants, native plants. And of course, in Europe, we always hear the case of the harlequin ladybird, so Harmonia axyridis, which is coming and coming again when we want to advertise classical biocontrol. I should say that Harmonia axyridis was not introduced. Was not introduced as classical biocontrol agent, but more as augmentative biocontrol agents. So this was not assessed as classical biological control agent because nowadays. The classical biocontrol agents, in most cases, especially in Europe and North America, Australia, and so on, they are screened very much for their specificity, and they will not be released if there is high risk of non-target effects on native biodiversity. Sometimes the problem is so enormous that we can take some risk. Sometimes the problem is less enormous, like, for example, when it attacks a flower pest, then, of course, it should be 100% specific. But of course now there are ways to assess the specificity of classical biocontrol agents, especially in weeds, which has been practiced for a long time, but also against insect biocontrol. Funding, yes. It's traditionally funded by public organizations because there is no benefit for biocontrol or chemical companies, classical biocontrol, because it does the work by itself. You don't sell classical biocontrol agents. Just as an example, the ongoing funding of the CABI, of the Drosophila Suzuki classical biocontrol at CABI in Switzerland was started with EU funding from the EU, FP7, not especially on that, but it was a larger project on Drosophila Suzuki, and then it continued with relatively limited money from the Swiss Federal Office of Agriculture, Swiss Federal Office of the Environment. We also got some money from the Loterie Romande, which is the equivalent of Française des Jeux, which is an enterprise of public utility, so it's also somehow public. We have also a funding from private partners, but usually it's more like growers association. It's not companies, it's grower association. And a good example like this is our biocontrol against the box tree moss, which is funded mainly presently by USDA, but also by the horticultural associations in USA and Canada. It starts actually with the FAO and the EU special representative for the South Caucasus and crisis in Georgia, because they wanted to make peace between Abkhazia and Georgia using the box tree moss as a common problem. So I went there several times, but the project stopped some years ago, and now it is funded by USDA mainly, but also some horticulture associations and so on. But in Europe, it's difficult to have this association paying for classical biological control, much more than. I should say also that classical biocontrol is more applied in other continents such as North America or Australia, New Zealand, than it is in Europe. Yes, this is, I think, the last slide. The main constraints, what are they? Well, first is it's not a commercial product. So of course there is no investment from private companies. So it's mostly publicly funded, usually poorly publicly funded. We have to try to grab money, except when it touches a development problem. There, of course, development agencies are more generous, but in Europe it's usually very difficult. Also, I should say the public funds for research are increasing, targeting support to the private sector. For example, Horizon Europe. Now it's very complicated to get money for classical biocontrol because we have to include support to commercial companies in the proposals. Otherwise, they don't fund these kind of projects. And of course, in classical biocontrol, it's not the best example for such type of funding. The legislations are increasingly complicated, especially for exporting and importing genetic resources. Countries are making things extremely complicated. From some countries, it's almost impossible to export biocontrol agents, and so for the yes, that's very complicated now. And also for releasing biocontrol agents, there are more and more legislation. But on the other hand, I think this is good because we should be careful and we should not release anything. There is also no European legislation. Every country does what he wants. Some countries are more relaxed than others. And then, of course, there are neighboring countries, and countries complain to the other countries that they have released things and so on. So this still happens. It would be nice to have one European legislation. And classical biocontrol sometimes is misunderstood and badly perceived by some groups. Some very important and environmental NGO, for example, often don't really understand what classical biocontrol is, and they systematically oppose any kind of introduction of an exotic organism somewhere. And I think with that you already mentioned that, so I can take a few questions if there is still some time. Yes. No, this is DGs for our tropical, for development biocontrol. But DGs is also very reluctant in paying for research. So we are usually paying the research with SDC, the Swiss Development Agency, and then the implementation can be taken over by DGs. Sure, yes. I mean, we work with so many countries in so many classical biocontrol is typically an activity which needs collaborations, because when you introduce, like for example, the Drosophila Suzuki biological control is done in collaboration with INRA in France and with Italian partners who have already released the agent, because they are a little bit faster to decide than the Swiss government. So, but yes, we are working with different partners with that.
Nicolas Inray. Yes, in the frame of this workshop, I think that it would be very relevant to think about international structure that could help also to collect fundings from different horizons, okay, and to be able to reallocate resources according to the actual need, prospection in the native areas, mass rearing in some location, and this could avoid to disperse small funding and to do the same thing maybe quite at the same time, but in different locations.
Yes, I fully agree with that, of course. It should be a European effort. In North America, it's not single states, but it's a whole United States and so on who are doing classical biocontrol. It's not state by state. I just if I have just 1 minute to take of this, I mean, we are working, for example, on the box tree moss. Lots of people in countries in Europe are crying that our box trees are disappearing, but sadly, the only people who are funding us for classical biocontrol of the box tree moss are the Americans, because the box tree moss just arrived, and although they don't have native box trees there, they're still confident that classical biocontrol can solve the problem. So if there is, we are really open for any kind of collaboration in Europe for also saving the box tree moss, the box trees in Europe, not only in the Americas, because otherwise we will have to send all our parasitoids to America. So if there is no more question, I will leave it to the case studies then.
Thank you, Marc.